Hello everyone, welcome back. So now we'll start with the next experiment, that is conductometric titration. So conductometric titration is nothing but the titration in which we are going to get end point as the conductivity changes, as the conductance changes. So the titration in which end point is determined by change in the conductance. So conductance is nothing but the current flows through the solution. So mobility of H plus ions or any ions gives the conductance. So this is the reciprocal of the resistance. So conductance C is given by 1 by R, reverse of resistance. So this is the unit of this conductance is ohm inverse. Here you can say see this is ohm inverse, or you can also say MHO, or Siemens is also the unit of conductance. So let us have a look on theory. The conductance of the solution is explained by considering Ohm's law. According to Ohm's law, the current flowing through the conductor is directly proportional to voltage and inversely proportional to resistance. As you know, this Ohm's law says I, that is current flowing, is directly proportional to voltage, or even you can say V instead of E also, and R is a resistance, that is inversely proportional to resistance, or also you can write E equal to IR. Here the resistance of any conductor is directly proportional to the length of inversely proportional to the area of cross section of the conductor. Therefore also we can write R equal to S into A, 1 I by A. So here the conductance is defined as, here the conductance of the solution which is placed between two electrodes of area 1 cm square and 1 cm apart. The conductance of the solution is depend on mobility of ion and number of the ion. So in acid you can consider the mobility of H plus ions. So this is about the conductance. So let us see the types of conductance. There are three types, namely specific conductance, equivalence conductance, and third one is molar conductance. So here specific conductance K is nothing but the conductance of the solution in which the conductance of the solution which are placed between two electrodes of area 1 cm square and at 1 cm apart, that is called as specific conductance. Here electrodes are placed of area 1 cm square and 1 cm apart, that also given as K equal to 1 by R, that K equal to Siemens per meter. Okay, so this is specific conductance. Second one is equivalence conductance, that is lambda. So this is the conductance of the solution when 1 gram equivalent weight of solution is placed between two electrodes of area 1 cm square and 1 cm apart. So electrodes also, these are placed between, and who has the area of 1 cm square and 1 cm apart. So third one is molar conductance, that is mu. It is the conductance of the solution when 1 gram molecular weight of solute is placed between two electrodes of area 1 cm square and 1 cm apart. So here just to categorize these three, you need to remember in first, that is specific conductance, you know the area of this electrodes are placed, that of area 1 cm square and 1 cm apart, that is unit. This is the standard, you can say. In equivalence conductance, 1 gram of equivalent weight of solution is placed, and in molar conductance 1 gram molecular weight of solute is placed between the electrodes which have the same surface area of 1 cm square and 1 cm apart. So this is all about the types of conductance. So next, that is, we have three cases here, that is conductometric titration, of three different cases. First one is strong acid with a strong base, second one is weak acid with a strong base, and third one is acid mixture. That acid mixture is having one is strong acid and another is weak acid with the strong base. So we'll see one by one. So first case is case 1, strong acid versus strong base. So in first case we have taken strong acid as a HCl and strong base as a NaOH. If the strong acid like HCl is titrated against a strong base such as NaOH, the conductance first decreases because the replacement of fast moving H plus ions by slow moving Na plus ions. See here, just observe the reaction. We have taken strong acid and strong base. So here the replacement of this H plus ions takes place by this Na plus ions. Here you can see this replacement of H with the Na takes place and acid and base together giving to form a salt, that is NaCl, along with the formation of H2O. As you know, this H plus ions and OH minus ions get neutralized to form this water molecule, along with that salt is going to form. So this is the reaction taking place in case of titration of strong acid and strong base. So after this neutralization point, conductivity rapidly rises with a further addition of NaOH, because also here the continuous addition of fast moving OH minus ions takes place. So here we can plot a conductance against, here we can plot a graph of conductance against, conductance against the volume of base added, that is volume of NaOH added, which is shown in the figure. So this point of intersection, these two, first as we know, as I said, conductance decreases and then after neutralization it increases gradually. So point of intersection, this intersection gives you the neutralization point, or you can say the equivalence point. So this is nothing but the volume of NaOH required to neutralize this HCl, that is strong acid. So this is about the first case, that is the titration of strong acid versus strong base. So now we'll move to the next, that is weak acid versus strong base. So here we have taken weak acid as a acetic acid and strong base, that is same NaOH. Okay. So now consider the titration of acetic acid CH3COH against NaOH. As I hope you know what is weak acid. So in strong acid, what you can observe, that is complete dissociation of ions. If you take HCl as a strong acid, it completely dissociates into water as H plus and Cl minus ions. So here if you consider acetic acid, it do not completely dissociates in water, as it gives acetate ions, which is not a complete dissociation. So this acid is called as a weak acid. So now this conductance of this acid will be initially low, because this acetic acid is weak electrolyte which do not dissociate completely. So when NaOH is added to acid, the salt is formed highly ionized, and this conductance increases on complete neutralization, as I told. So as this acetic acid is treating with the NaOH, so initially the conductance slowly increases, and once the neutralization is over, then increases on further addition of this NaOH. So this is the reaction acetic acid and NaOH, weak acid and strong base. Here again this H are replaced by this Na, that gives a sodium acetate salt along with the formation of H2O, that is neutralization. So this is about the reaction. So now we'll see the graph. So graph also here, the in y-axis conductivity is plotted, and in x-axis volume of base, that is addition of NaOH strong base. So here initially, as this acetic acid is treating with the NaOH, the conductance is increasing slowly, and once the neutralization completes, the sudden increase we can observe here, sudden increase in the conductivity. So intersection of these two lines gives you the amount of NaOH which is required to neutralize this weak acid, that is acetic acid. So this is the second case, weak acid versus strong base. So we are moving to third case now, that is mixture of strong acid and weak acid versus strong base. So in this case we are taking both the acids, which will be, one will be strong acid and another will be weak acid. So that is titrating against a strong base. So here we have taken strong acid as a HCl and strong base, that is NaOH, and weak acid acetic acid. So first we taken mixture and then we are titrating it with the NaOH. So this is the mixture we are taking here. So as strong acid like HCl is titrated against a strong base, that is NaOH, the first we already saw, that is conductance decreases. Already we have studied first conductance decreases due to displacement of fast moving H plus ions with slow moving Na plus ions. So this is about the first case, strong acid and strong base. So that reaction you can see, first HCl is reacting with NaOH and formation of salt along with the water molecule. So this is the first case. So once all this HCl in the beaker is getting neutralized, so now this NaOH strong base will react with the next weak acid, that is acetic acid. So second reaction we can see, that is acetic acid, and then it is treating with the NaOH, gives sodium acetate along with the formation of water. So remember here, first when you take the mixture of two acids, NaOH, first it will prefer to react with a strong acid because it is a strong base, and then once all the strong acid is getting neutralized, now it will react with the acetic acid which is left in the beaker. So here first case, both are strong acid versus strong base, so the conductance decreases, and then when you are treating this NaOH with the acetic acid, the conductance slowly increases. So this is how the reaction taking place when you take the mixture of weak acid and strong acid. So here we can observe change in the concentration of H plus ions, so conductance varies. So next here, when you take weak acid, it does not get neutralized initially because it is because of common ion effect. So in presence of excess H plus ions, the ionization of weak acid is taking place. So as weak acid we have taken, that is acetic acid, which ionizes gradually after end point, and these available H plus ions are neutralized by giving the second end point. So here you can observe the graph. So as I said, so first initially the conductance decreases first when this HCl is reacting with the NaOH, so conductance decreases. So once all this HCl is getting neutralized, then NaOH start reacting with the acetic acid. When it is reacting with the acetic acid, formation of sodium acetate taking place. Due to formation of salt, this conductance gradually increases but not sudden. So once all the acetic acid also neutralized, we left with no H plus ions or no acid ions. So whatever NaOH minus NaOH solution you are putting in the beaker, that OH minus ions are free. So due to free OH minus ions, conductance sudden increases. So remember, three cases are taking place here. First, due to reaction of strong acid and strong base, conductance decreases. So when it comes to weak acid and strong base, conductance increases but gradually. And once both the acid get neutralized, then we left with the free OH minus ions, hence the conductance suddenly increases. So intersection of these two lines gives you the neutralization of HCl. So neutralization of HCl is nothing but the amount of this volume of NaOH which is required to neutralize HCl acid only. So So this come to this point, that is intersection of these two lines gives you the amount of NaOH required to neutralize both the acids. This is total acid, and if you want the amount of amount of NaOH which is required to neutralize acetic acid only, you just subtract this higher value minus this value, so you will left with this amount of NaOH which is required to neutralize the acetic acid. So this is the third case. So after this neutralization point of HCl and acetic acid, the conductivity, as you know, conductivity rapidly rises with the NaOH addition. So this plot of conductance, here it is conductance against the volume of base added. So this is very important, and the intersection of two curves gives the neutralization point of both the acids. Here it is. The neutralization points gives you the neutralization or the amount of NaOH required to neutralize both the acids. It may be strong or weak. So let us study the advantages of this particular reaction. So first is, we can study the mixture of acid can be titrated. So mixture of acid, as we have taken, one is strong, one is weak, so it can be titrated by this conductometry method. Second one is, indicators are not used in acid base titration. Actually in some titrations, acid base titration, we are using indicator which gives a change in the color, but in this experiment we are not going to use any indicators. So next one is, very weak acids can be titrated by this method. Fourth one is, it can be used with the colored solutions also. So this is all about the advantages of this conductometric titrations. So this is all totally about the conductometric titrations, where we have studied the three cases. First case is strong base versus strong acid. Second one is strong base versus weak acid, and third one is strong base versus the mixture of acids, that is, one will be weak and one will be strong. So I hope you understood. Thank you.